This is the project that's showing about design and simulation of PV battery and fuel cell based microgrid system. In this microgrid part, we have used three energy sources. First one is PV, second one is battery, and second one is battery, and third one is fuel cell. And these three renewable that energy sources are connected with common DC bus, and the common DC voltage is connected with three-phase inverter, and the three-phase inverter is connected with residential load. Here, that PV control part, first energy source is PV. The PV is connected with boost converter. For that boost converter, we used one switch. For that boosting switch, we used pulse width modulation from PSO MPPT technique. Just open this block. You can see the PSO optimization. That optimization duty cycle is connected with MPPT. Further, after processing that MPPT, we can get finalized duty cycle. That duty cycle is connected with PWM technique. Then we can see the pulse modulation. That pulse modulation signal is applied to that boost converter switch. And here we can see that converter current and converter voltage. And the second energy source is battery. That battery is connected with two switch boost DC to DC converter. And here we can this is the input voltage of the battery, and this is the output voltage of the battery. So this is fuel cell. This is two switch DC to DC converter. Here we can see input voltage, and this is output voltage of fuel stack. And these three sources are connected with common DC bus. Then the DC voltage is applied to the three-phase inverter. Then we can operate three-phase. We can take three-phase load here. For three-phase inverter, we used DQ control technique. That means the three-phase AC voltage is converted into DQ form. After that, after the DQ form, we can DQ to again ABC. That ABC we can take reference for pulse width modulation, and we can give gate pulses to the inverter, three-phase inverter. And this is a filter which is used to remove the noise from that generated AC signals. And this is input voltage. That is what we are given in that in three-phase inverter. And this is a voltage of three-phase load. So this is the scope for input voltage of DC and three-phase output voltage of AC. In this scope we can see the both output representation. This is three-phase bus which is used to take voltage measurement and current measurement. This is a resistive three-phase resistive load. And this is 13 bus system. If you want to connect with this entire system in the 13 bus means the result will be different. You can see the difference here. So without connecting that 13 bus system also, you can measure the output. This is the extra thing. If you want means you can use in your project, otherwise leave it.